All right, this one's going to be the last video for this lesson. Let's get right into it. Most of you probably took an ACT test at some point. ACT test is a standardized test taken by high school students going into college. According to the ACT.org, the company that actually runs the test, the mean ACT score for graduating students in the United States in 2024 was 19.4. So we're going to call that the mean of US down here. Suppose a random sample of 30 Skycrest high school seniors is selected and their sample mean ACT score is 20.6 with a standard deviation of 5.3. Okay, so our sample, we have a sample of 30 and the sample mean is 20.6 and the sample standard deviation is 5.3. And we're not told any generalized population standard deviation. At the 5% significance level, let's try it, I don't know, pink. Perform a hypothesis test to test whether the mean ACT for Skycrest high seniors is different than the national mean. All right, so we'll try to go a little faster this time. We don't know sigma, so this is going to be a t-test. The requirements for that, we need a random sample, and it told us that here. And we need either a sample of 30 or higher, or the population data is approximately normal. And our sample is 30, so that works too. Our hypotheses here is that the mean that we're testing out is the same as the other mean we were told. So here the mean is about the Skycrest High population. And we have to assume it's the same as the general population. And our claim is that it's different. So different becomes a not equal symbol. Okay, this different here. We're not testing if it's higher or lower, just different. Okay, so this mu here represents Skycrest High mean ACT score. Not the 30, all Skycrest High seniors. We don't know what it is, but we got data for 30 of them. So we're gonna skip this for time's sake. And we'll do the calculator instead. So we're doing a t-test. The null hypothesis is that the ACT score is the same, the mean ACT score. The sample mean, so their sample is higher than the national mean, but we have to do more. So every time we take a sample, it could be different. So it is higher, but is it real or random? And our sample standard deviation is 5.3, and the sample size was 30. And this time our alternative hypothesis is that it's not the same, not equals. We'll hit calculate, and so that we're down here, but yeah, so it echoes out our alternative, the test statistic t, the p-value the sample mean and a sample size. That's what it's telling us, just to verify. All right, so we'll just jump down to here. Was this at a 5%? Yes. Which one of these numbers is smaller? Alpha is smaller. The p-value is bigger than alpha. When the p-value is bigger than alpha, we fail to reject the null hypothesis. So what we're left is, we had two ideas to start with. And we were unable to throw one of them away. So when we fail, we had two ideas, we still have two ideas, so we just don't know. So in terms of real world conclusions, we'd say something like at 5% significance, we have insufficient evidence of a difference. That's a mean ACT of the two populations are different. I don't know what to call it, like just all United States high school seniors. So just to re-emphasize, we're always we're generally hoping to reject the null hypothesis so that we can make our claim. In this case, we had insufficient evidence to make our claim. So we don't know. We're not saying they are the same. We're just saying we don't have strong enough evidence that they're different.